Alright, day 3 for chapter 3. Alright, actually, let's check this out. Before we do day 3, let's make sure, make sure that you have a project in which the crabs move, they turn randomly, and the crabs eat the worms. So if you don't have that done, revisit chapter 2, but here we go, day 3. This works. So this is basically what you have, and it works well to do all the things we just said. And if you don't have it, copy it. But check this out. Our ACT method is getting longer and more difficult to read. So if we look at the ACT method, you can't just look at this thing and kind of figure out what it does. It'd take you a little while to read through, like, okay, what does this do? Okay, yeah. So basically, if you get to the edge of the world, it turns a little bit. Let's see, what does this do? Oh, okay. So it takes you a little while to go through it and actually figure out what it does. Okay, so what we're going to do is we're going to move some stuff around. So we're going to start off with this. If can see the worm class, eat the worm class. We're going to move that down into its own method. Right now, it's in the ACT method, and we're going to turn it into its own method. Okay. If we continue to add code in this way to the ACT method, it will continue to become longer and longer, and eventually it'll be super hard to understand. So we can improve this by chopping it up into smaller pieces. This makes it easier to understand. That specifically, it makes the ACT method easier to understand, and it's called threaded coding. All right. Actually, I'm going to hit escape, and I'm going to change that real quick. Okay, let's do that again. All right, it makes the ACT method easier to understand. It's called threaded coding. Okay, so from now, so I'm gonna teach you how to do threaded coding. But just so you know why we're talking about it, from now on, I expect all of your projects to follow threaded coding techniques. Okay, all right. So check this out. Our ACT method is longer and more complicated. As we've said, we need to make it simpler by chopping it up. So let's move this to a new method. So instead of in the ACT method saying if can see worm.class eat worm.class, we're going to cut that, and then we're going to add these comments. You have to use the comments, okay, and put it here. So you're going to make its own method definition, public void, look for worms, and then you're going to paste the code there. Okay, and by the way, make sure that your curly brackets are all like this. If you don't have the curly brackets correctly, it's not going to work. Okay, do that. Make that method definition. Okay, so now there's what. So now that we pulled that thing out of the ACT method, we actually have to do a method call. So you have to say look for worm, and then the semicolon is always a do it. Whenever you see a semicolon, it's a do it. So if you see something like this, if, say, hey, are you at the world's edge? You normally have a little curly bracket. But when it's a do it, like, okay, now I want you to turn 17, there's a semicolon. Okay, so this is a do it. So look for worms, it's going to go down and read that definition you wrote for the look for worm method, and then that's going to do it. Okay. Okay, question. Does this make our crab do anything different? So run it, make sure your project runs, and answer the question, what does it do? So the question is, what does it do different? Okay, and the next question is, why did we just do what we just did? What's the purpose of what we just did? Okay, so just so you know, this is a method call. It's saying, in your ACT method, it's saying, okay, do this, look for worms, right? So it's going to do it, but you have to define how to do it. And so it says, well, how do I look for a worm? And it's like, oh, okay, you come down here, and it tells it step by step. Here's how you look for a worm. So here's the call saying do it. Here's the definition telling it, explaining how it does it. Okay, so answer these questions, or not answer the question, but copy these notes down. Remember, red means write it down, green means go. Copy that down. All right, the other piece is you have to have comments. Okay, comments are important. If you get a job as a programmer and don't do comments, you won't have a job as a programmer very long. Everybody expects them. They're needed for the programmers. You are not going to be the only programmer who works on something. The guys who did Halo, the first Halo, were probably not the same guys who did Halo version 3. So the programmers who came after them had to understand what they had done, and so the comments are very helpful for the human people who come after you and for me to understand what you're trying to do. Okay, so these are comments. You must have comments. Alright, here's some things. The discipline of object-oriented programming is based on methods, subroutines that are attached to objects or object classes. What that means is you just wrote a method definition for look for worm, okay, and that's attached to the crab. Okay, so whenever you do object-oriented programming, you basically have these guys, these robots, or these classes that you make, crab, and it has these methods, the things that it knows how to do, that are attached to it. And that's the discipline of object-oriented programming. It used to not be this way. Alright, in the compilation technique called threaded code, the executable program, which is the ACT method, okay, the ACT method is basically a sequence of subroutine calls or method calls. So you're just saying, hey, check key press, move, look for worm. All right. So you notice that we've made the ACT method very simple, and now it's easy to understand. I know what check key press does. It's like, okay, we got to check to see what the player is doing. Move. Okay, we know what that does. He moves. Look for worms. We know what that does. All right. So it all makes sense. Okay, so in the same way, we just move some stuff out of the ACT method into its own method definition. So now your job is to create another new method named random turn. Select a code that does the random turning and move it from the ACT method to the random turn method. Then call this new random turn method from your ACT method. Make sure to write a comment for this method. Do that. Now you're going to do this again, create yet another new method named turn@edge. Select the code that checks whether we are at the edge of the world and move it from the ACT method to the turn@edge method. Then call this new method from your ACT method. Make sure to write a comment for this method. Do that. Alright, so now your ACT method should look like this: turn@edge, random turn, move, look for worm. Okay, your ACT method should be super simple like this. And answer these questions. Ready, go.